Good morning, team. Hey, whoa, wait, that doesn't make sense. Okay, let's try that again. Good morning, team. Welcome back. I'm Corey, and we're about to get started on day 10 of Advent of Code in Rust, finally in the double digits. If you missed the previous days, check out the playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's get started. Okay, let's get started on day 10. Day 10, Cathode-Ray Tube. You avoid the ropes, plunge into the river, and swim to shore. The elves yell something about meeting back with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritize getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be of much immediate use. Unless, that is, you can design a replacement for the device video system. It seems to be some kind of cathode ray tube, screen, and simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Start by figuring out the signal being sent by the CPU. The CPU has a tiny register X, which starts with the value 1. It supports only 2 instructions, add X, V. It takes 2 cycles to complete. After 2 cycles, the X register is increased by the value of V, and V can be negative. A no-op takes 1 cycle to complete. It has no other effect. The CPU uses these instructions in a program, your puzzle input, to somehow tell the screen what to draw. Consider the following small program. No-op, add 3, add -5. At the start of the first cycle, the no-op instruction begins execution. During the first cycle, X is 1. Apparently we start with 1. The no-op instruction finishes termination doing nothing. At the start of the second cycle, the add 3 instruction begins execution. During the second cycle, X is still 1. During the third cycle, X is still 1. After the... Okay, yeah. Maybe you can learn something by looking at the value of the X register throughout execution. For now, consider the signal strength, the cycle number multiplied by the value of the X register during the 20th cycle and every 40th cycle after that. That is during the 20th, 60th, 100th, 140th, 180th, and 220th cycles. For example, consider this larger program. The interesting signal strength can be determined as follows. During the 20th cycle, the register has a value 21, so the signal strength is 420. The 20th cycle occurs in the middle of the second this, so the value of the register is the starting value 1, plus all the other add X values up to that point. During the 60th cycle, register X has the value 19, so the signal strength is blah blah blah. The sum of these signal strength is this. Find the signal strength during the 20th, 60th, 100th, 140th, 180th, and 220th. So these cycles. What is the sum of these 6 signal strengths? Okay. Wow. So we have something, and we want to get the cycles out of it. We want to know what's happening at the 20th cycle, the 40th cycle, and all of that. Okay, and it happens at the end, right? So during the third, it's still 1. After the third, the add X finishes, setting it to 4. Yep, okay. So there's just 1 in the middle where it stays the same as it was before. Cool. We can deal with that. Okay, so I'm not sure exactly where we want to get started here, but first thing we definitely want to do is make our cargo workspace. Cathode ray tube. Cathode ray tube. The library, we're going to name it cathode ray tube. CD to 10. Go ahead and add it to our cargo workspace. Dash cathode ray tube. Okay, I already went in there. We can cargo test it. Yay, the 1 default test works, and we're gonna delete it. Okay, so I actually don't really know where we're gonna start here, so let's just think about it. I think we can just go through these. Well, obviously we need to parse these, which shouldn't be too hard. There's not very many instructions. And then I think we just need to go through them until we've hit the thing. I think if we go through them manually, it'll be easier. Okay, let's do this. Let's start by parsing it. So we're gonna have a command enum. It has two commands, add x, which takes, which has a number. We're gonna call it a u size, an I size because it's signed. And a no up. Okay. We want to do an impl block on command do where we can implement the function parse, which takes an input string and returns a self. So we're going to go line by line. We're doing this a little backwards of how we've done it before, but we're going to split on the space. Let mutable split equals input dot split on the space. And then we're going to do let command equals split dot next dot unwrap. We're going to say we know we're going to get a command. And then we may or may not get something after it. So I think what we want to do is now we want to match on the command. Reference the command. I'm actually just not really sure why. It's gonna matter either way. So if the command is no op, then we just return a command of no op. If it's add x though, then we do let amount, which is a u size, equal split dot next dot unwrap dot parse dot unwrap. We're going to do it all in one line here, and then we can do a command of add x of amount. U size though. I wanted to parse that to an I size, and actually I don't need to tell it what it is because it's going to be able to figure it out from knowing what our add x command holds. And then if you get anything else here, we're going to panic on command do not implemented. Awesome. Okay, so then we can parse this. So let's just do a public function part 1 just to get the scaffolding set up. And it's going to return a u size. Wait, is it always going to be a u size? I don't know. Let's make it an I size because I think we're just going to be dealing with negative numbers and it's going to be better to be consistent. This is just going to do a to-do for right now. It's probably going to start debugging this in a second. And then we have a test function, test example input part 1. Let input equals include string, for example, input. And then let answer equal part 1 of input, and assert equals that answer is that 13,140. We need to actually add that example file, example.input. That would be this box. Okay, and then in part 1, all I'm really going to do is do let commands be a vec of commands equals input dot lines dot map command parse. Collect. Okay, so now I can debug my commands and we will just make sure that they look right. once we add the derive debug so that we can actually implement the right thing. And now when we run this test, we should see, here we go, nice and parsed out. Let's go to the first ones, just to 15, negative 11, 6. 15, negative 11, 6. Okay, awesome. So we are ready just to start going through here and counting our things. So let X register equals 1, because apparently our X register here starts at 1. And then for C in commands, we're gonna just match on C. So if it's a command no op, so then actually we also want to do let cycle count equals 0. Cycle, oh, so I guess we will add this at the end, cycle count plus equals c dot cycle count. We'll add a function for that. Okay, so but then if we match, I guess we don't really want to match there. We just want if let command at x of amount equals c, x register plus equals 1. No, that's not right. We want to add amount to it. So this is like kind of what we want. Let's implement cycle count really quick. It's a match on self. If it's a command no op, it's 1. If it's a command add x, it's 2. I32, nice. I like that it knows what I wanted it to be. Can't assign mutable variable twice. Well, good thing I wasn't actually trying to do that. Okay, so then what do we want to do here? We might have wanted to read before this. So really what I want to do is, do I want to just do for while just loop? No, I think I like it this way better, but I might need a let original x equal x register. Yeah, we're just gonna make a copy of it here so that we have both here. Okay. So now I can just start counting. Like, I guess I could just do, let's just check the first one. If cycle count equals or is greater than or equal to 20, if actually let's do, yeah, okay, well that's fine. If cycle count is exactly equal to 20, then we want to take the original x value. Else we want to debug, oh no, that's the opposite. This is where we want to do x register because it happened exactly like we wanted it to. If it's anything else though, we want to do original register. And then here we just panic because we don't know what to do. That doesn't make any sense. We have to keep going. We'll panic at the to-do down there. Okay, so does this output anything useful? It debugs a lot of things. Oh, the last thing it debugs, I guess, is 17. So at the start of the first cycle, the note begins. Okay, so wait a sec. Consider during the 20th cycle. So during is before the 20th, so after the 19th. Actually, wait a sec. I'm getting way more of these than I expected to. Oh, because I'm just not even incrementing my cycle count. Oh wait, no, cycle count equals adding cycle count. Oh, okay, so this one should be increasing. Oh, I said if it's greater than, and then I didn't do anything in the else. That's what I wanted to do here. Else panic. Just testing. There we go. Okay, that'll at least do what I wanted it to. Now we shouldn't get as many debugs. I only got that one. Oh yeah, no, I can't have an else because then it won't do it ever. I'm silly. I want to do a panic after it. Uh, uh, we only want the first. That makes sense. That's what we want to do. I don't know what I was thinking. Okay, original 21. That makes sense. That's the right answer because this one was supposed to be during the 20th cycle. It has the value 21, and then so we're supposed to do 20 times this. Okay, so let's. I guess I just want to get the cycle counts I care about. So like const imp, important cycle counts. I don't really like this. 20, 60. Is that what it is? It's at 20, 60, 100, 140. Hi, Bobby. My cat Bobby is singing to everyone while I do this puzzle. Okay, so those are the ones we care about. That's fine. It's easy enough. Those are going to be U sizes, so I can index things by them. Oh, not just a U size, an array of 6 U sizes. I don't really care what this is. Will you just infer it for me? Nah, it needs me to tell it for the constant. Okay. Let mutable current important cycle count equals 0. Cycle index or something. Let's just do that. And then let mutable important and then what did they call these? These are signal strengths. Signal strengths is just a new vec where this is gonna be a vec of I sizes. Phew. Okay, so now I can do if cycle count is greater than or equal to important cycles at current important cycle index. If cycle count equals this thingy, then we do current cycle index at 1. We can move on to the next thing. Actually, that's probably gonna be the last bit though. The next thing that we're gonna do is do let signal strength equals the important this thing again at current and cycle index times the I don't know, what is this? X register. So like a chosen X register. And then this is how we choose the. Oh, we're already in the equals here. Got it. Undo. Delete. Yeah, I did want to delete that. Okay, so we're already in the equals. So this means it's X register. Except actually, I just want to do this though. X register else original X. I love how I don't even think I checked like more than a single value here. Let chosen X register equals that. Let that. And what do I do with single strength? Yeah, so I then do important signal strength stop push signal strength. Okay. Let's see, now I have some things not closed correctly. If that closes that, this gets closed here. So do I have an extra closing thing somewhere then? Is that what you're telling me? No, I have there we go. Too many. Yeah, as an I-32. As an I-32. Chosen X register. Oh, as an I-size. Oh, that one actually said I-32, so we're gonna leave that there. I don't know why though. Okay. As I says again. As I-32? Yeah. Oh, 32 versus 64. Got it. Why is cycle... didn't I make cycle count, though? Oh, yeah. I just want to be consistent. Everything should be an I size. Besides the things that are U sizes, I guess. I don't know. It's fine. Okay. Don't need this anymore. This can just debug out the important signal strengths for me. I guess I still do need the to do at the bottom for it to compile. And run the test. Okay, so our important signal strength is index out of bounds. Nice. If current is greater than the... You hear Bobby? He is not happy. Break out of our loop. Stop processing things if we are past the things we care about. Index out of bounds. Line 50. Line 50. Yeah, wait a sec. Didn't I just say that, if it was greater than or equal to? There we go. Okay. 420, 1140, 1890, 280. Oh, wait, that one's so close. Okay, that one's wrong. During the 220th, the value has 220 times 18. Yeah, okay. So I must have timed it by... Oh, it's just, I see, it depends. I'm just off by a bit. But I think that's actually because in the version that I had before I made it do this, which I don't think is going to be easy to get back to, of course. Nope, it would be too far. I think I need to compare at an off by 1, though. These ones might need to be 19. Like, they all might need to be -1. Dot map. Dang, I thought I could map that. What's the error? Can't call non-const function map in constant place. Oh man, that's okay. I could just make this a let instead of a const. Rename symbol just to important cycle counts. Then I can map it easy. Does that give me the right answers? No, now these ones are just off by silly numbers. Wait a sec. So all of these were right except that last one? Yeah. Okay, so let's just add some debugs, I think. When I go to do this push, let's debug out the cycle count The chosen X register, sure. Times the signal strength, sure. Let's just get all of this. Maybe that's all I need. Okay, let's go run that example. Okay, so like this is cycle count 21 and the chosen X register is 21. Yeah, okay. Cycle count 61. Yep, so it's always, these always have been one off. And the 1800, that one's right? Yeah, during it, it has the cycle 18, has 19, 21, 21, 16, and then this is 19. Okay, so what's going on with that one? Why is that one 19? I don't know which one that is. The 220th cycle. Do I have the command that I could print out here? That would be helpful. Okay, so during, it's an addex of 1. Of course it is. Okay, so the cycle count is exactly 220, so it should have happened already. So let's print out both of them and see if it shows the X register and original X register. Okay. So chosen 19 here. X register is 19, original is 18. Yeah, so 220. Wait, it went up by 1. Oh yeah, because adding 1. Yep. That's interesting. So this feels like I'm doing the right thing, but I can't be doing the right thing because we are so close. During the 220th cycle, during the 220th, not after the 220th, during the 220th. So I want, yeah, that's what I was saying before. I want after the 19th. After the 19th is the same as during the 20th because we start with the first. So that would be after the 0th. Yeah, so we will add 1. Yeah, so we do want to do the add 1 thing because I might have done subtract 1. X, no, it is -1 because if it's during the 20th, that's after, during the 20th is after the 19th. During the first is after the 0th. So during the 20th is after the 19th. Yep. So if we stop and we're exactly on the 19th, we're good. And if we're the 20th, yeah, so it's either, should be either 19 or 20 here then, in our first thing. Cycle count 19, chosen register 21. Okay, see, but then that's what's wrong here, because then I need to do, when I do the multiplication here, it's this plus 1. All the parentheses for all the adding and all the type conversions. Okay. Now, what do we get? Now we get 3960 as the last number. It was an off by 1 issue. Okay, so then I want to sum those and get this. Okay, important signal strengths dot iter dot sum, and the example passes. Awesome. Let's do my input. Test my input. I will need to copy that because I don't have a my input yet. Add new file, my.input. Boom. Okay, let's say that my input is going to be 13,140. It won't be. 17,940. 17,940. Nice. Day 10, part 1. Commit anyway. We might do some cleanup really quickly before we move on. We had a lot of debugs. If nothing else, yeah. Let's get rid of that big debug. Any other debugs? No. Okay. But some of this is still a little messy. I'm adding and subtracting. What if I just get rid of the minusing one here, get rid of the plus oneing here, and here we do -1. So reduce it to 1 places. So if the cycle count is greater than or equal to 1 minus the one where we care about, we start thinking about that, just because of how that works. So this should still pass these 2 tests, I think. It does not. Oh no. Okay, so they both change. So I guess I should just undo this. Discard. And make sure the tests still pass on the committed version. This one I didn't change from the answer of 17,940. 17,940. Okay. Run these tests. Now they pass, but we still have the debugs. Remove the debug. They all pass, and everything is looking better. Fix part 1 unit test. Commit anyway. Okay, and we will be off to part 2. It seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of it. So it's that position and 1 on each side. In this system, there is no such thing as vertical position. If a sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. Don't understand that, but that's okay. You count the pixels on the CRT, 40 wide by 6 high. The CRT screen draws the top row of pixels left to right, then the row below that, and so on. The top leftmost pixel in each row is in position 0, and the rightmost position is 39. Okay, so these are 0 to 39. Like the CPU, the CRT is tied closely to the clock circuit. A CRT draws a single pixel during each cycle, representing each pixel of the screen as a ampersand. Here are the cycles during which the first and last pixel in each row are drawn. Okay. So by carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel, otherwise the screen leaves the pixel dark. The first few pixels from the larger example above are drawn as follows. Sprite position. So like this is just a line. During cycle 1, begin executing the add. During cycle 1, CRT draws position pixel in position 0. That is close to 1 because X starts there. Okay, so yep, there's that. Finish executing add 15. It's now 16, so this happens after, and this is done during. Okay, so then we start doing the dot. I'm not sure what sprite position is at the end of each cycle. I don't understand that. Sprite position. Current CRT row sprite position. Oh, this is just showing the sprite position irregardless of the current cycle. Okay, that's fine. It's not helpful to me, but that's fine. Allowing the program to run to completion causes the CRT to produce the following image. Render the image given by your program. What capital 8 letters appear on your CRT? Oof. Okay, so I actually have to render my grid and read out the capital letters that I see. Okay, so now I do need to go pixel by pixel. And I need to figure out if it's lit or not. And it's lit if it's my row. Okay, okay, okay. So this is every cycle now. So now the problem is that I didn't go cyclically in my CPU. I don't have a thing that just goes for every cycle. So I think now I have to change so I have something that goes for every cycle. So like we can do a loop. Where I guess I actually want to do let's see equals commands dot pop dot except we ran out of commands. We ran out of commands. So if we ran out of commands before breaking out of the thing we care about, then that's not good. I think that's what I'm going with. Then we get rid of the for loop for commands because we're doing that differently. Let mutable commands. Okay, so now that's actually like probably pretty close. So let current command equal none. Actually, so I guess this is current add x command because that's the only thing that's going to go in here. This is going to be mutable. So then I think what we do is if we already have that right here. If okay, first we want to do if current. Okay, so we're starting a thing, starting a CPU cycle during a CPU cycle. So this has to be at the start of the CPU cycle. It just makes sense. And then at the end of CPU cycle. Okay, so at the start of a CPU cycle, we actually might not pop a command. So if let some current command from current adder command, then we do current command. We'll just pass this through. Else we will do this. There we go. Let C equals this goes inside. We do that goes there, and somehow actually that works out fine. So current command here. I think the easiest thing to do is actually just make my command copy. Clone and copy. Okay. So if the command, if there was a command running and it's an addx command, then we'll set that to the current command. Else we just grab a new command. That's not gonna work. Next command. If next command. Wow. Okay, why is this so hard? At the beginning of a cycle, at the beginning of a cycle, if there's a command that's already running, that's the command that's running. Easy. Else, wait a second. Okay, at the start of a cycle, if there's something already running, we continue. This is just a continue. If something is already running, we skip this CPU cycle. But how do we skip this CPU cycle? No, if it's already running, that means that we're done with it because it was running for added it for one CPU cycle, and then it lasted till the next CPU cycle. So if there's something running, we want to, this is when we're going to use the thing as this. So here we know that this is going to happen. But this is at the end of command. So now this is, so this is where this is. Where amount is current command dot zero. It's just in my current command. Okay, so but if there wasn't a command, we pick it off, and then if let some next command equal, oh no, not, this isn't what I want. I want if it's an adder on the amount that if it's equal to the next command, then current command equals command adder x of amount. Oh man, this is just all a mess. Okay, so now we would say that if we pulled off the next command and it's this, and then I guess this is an else for hopefully not Copilot, but Rust Analyzer can help me extract this. Nope, it can't. It could do make my if let a match though. I want to do this. Pull you out, put it over there. Get rid of that, get rid of that. There we go. Okay, so the current command equals, okay, so when we pick off something, we do this, and then I guess if we picked it off, we're going to continue looping, and that's where I can just have C be this. C here is just current command. Cycle count. No, that's not right anymore. Okay, so if, okay, so now I want to do, I lost the increasing. I lost my increasing because I had amount here. If let, oh wait, no, so what is current command? It's a C. Okay, so if let command of an adder x, this is weird. This is so weird. I don't like how any of this is structured. But that's fine. If that's a C, then we do x register plus equals amount. But this is at the end of a cycle. End of cycle. So this is the middle of cycle. Middle of cycle. If cycle, so the other thing that we do here is cycle count. Oops, is we increase cycle count. Cycle count plus equals 1. If cycle count this, if cycle count is greater than or equal to that, sure. I think we can actually get rid of this whole subtracting 1 nonsense here though. So if cycle count is equal to the one we care about right now, chosen x is just going to be x signal strength. This will be easier. Chosen x register, this is just going to be whatever the x register is now because we're at the right time. This doesn't need to be -1 anymore. Okay, signal strength is looking good. And then we can add this all up to here. Now we'll actually use that signal strength, store it in our array, And I think now we can be done with all of that code. Any chance we still pass the test? No, that would have been way too nice. Okay. Big negative number instead of the number we are looking for. Okay, so let's just read through this. Something is probably pretty wrong here. Okay, so we start a CPU cycle. If there is something already running in the AddX, that's what we're going to do. If there's not already something running, oh, here, this is where we need to do the middle of cycle for both things. This continue happens too soon. And the end of cycle already has this on it. So current command is a command. I could just, I think we'll set, I set current AddX, yeah, okay, and then all I actually do here is make it a command no op, because that just means we're not going to do anything during this cycle. Is that any different? No, we're still at a very, very negative number. Okay, so we're gonna have to add some more debugs and see what's going on here. Let's just start off with a really easy one. Let's just debug out cycle count each time. Let's just make sure these numbers go in order. I guess they have to, right? No, not necessarily. I could be increasing it by something different. They definitely do though. Yay! Okay, cycle counts go in order. Awesome. They go up to 220 and then we break. I guess the other thing I could do is just debug out the important signal strengths just to see all of them. Okay, where's the negative numbers coming from here in my signal strengths? Something feels off about that. Debug out the, well, important cycle strength, sure. Important cycle counts at current cycle index. Yep, that and the X register. Yeah, I guess both of those things at the same time would be nifty. Yeah, so the X register is just a crazy negative value by here. What are we doing to the X register that's just making it go crazy? Debug the X register. Do that after. Let's just see it changing the X register and cycle count. Okay, so... Oh, cool, we don't even get to go all the way to the top because there's too much output. I wore this slightly itchy sweater for this video, and now I'm regretting that decision just a little bit. Okay. Is that any better? No, wait, cycle count. Oh yeah, there we go. Why is the X register starting at -10? Oh, because that's not the beginning. We're getting close, but I'm still not seeing everything. What do I not need here anymore? Let's not do that one. What's going on here? It's still not giving me cycle count of 0. Why are we not seeing so... Oh, whoa. Ah, everything's going crazy. Okay. Let's just read through this code again, see what we're doing. Cycle count 0, X register of 1. Yeah, I liked seeing cycle count at the very beginning. If there was a command left over, that's not right. If there, at the start of a command, at the start of a cycle, either we're gonna do an add at the end, or we're gonna no op. We're gonna do an add at the end if there was an add from last time. If there, oh, and if there was, we need to do current add x command equals none. Because we're not doing one anymore. There we go. I think I was repeating add x commands like in nauseum. Not in nauseum, but like for a long, long time. Okay, that's closer. Well, maybe closer. I don't know. These are still completely not the right numbers, but that was definitely a big thing. So cycle, we don't do an X register until we get 5 in for -10. Okay, that seems fishy. Okay, go back to code. But I kind of got lost in what's happening here. So if there was a command before save, there isn't now. Now we're gonna work on the command from last time. And then in the middle of the cycle, here's where we wanna, like, I liked this. Well, actually, I guess I want where we are changing the X register at the end of the cycle. If there is a command, current addx command. Can I set that? I don't know. I'm just a little confused here of how I want to do this. Oh, wait a sec. Am I popping commands? Oh my gosh. Is there like a shift method that'll give me the first one? I want to pop the first. Remove index 0. Remove index 0. If you'd like to remove elements from the beginning of the vec, call pop front on a vec DQ. Yeah, well, I don't have a vec DQ. Could I like just get a vec DQ instead? Oh, cool. I can. And then this is just pop front. Is that going to make the difference? Because that would be awesome if I was just counting, if I was just doing my commands backwards. Ooh. 420. Ooh, that looks much, much closer. Is it just the last one that's off again? Because that means it's an off by 1 issue again. I've already fixed that once. 420, 1140, 18, 290, 280. Yeah, okay, so this one is the one that's off by 1. Okay. Phew! Doing those in the reverse order was kind of funny. Was gonna be hard to track down. Kind of just got a little lucky. Because my code is kind of a mess. Okay, so what is happening is we're not counting the thing at the right time. Because are we... Okay, so the cycle count is 220, and I don't know if it's that we are doing it too early or too late. Because I want to get during the 220th cycle, register has the value of 18. So let's do cycle count and this whole thing. Okay, debug out that. And for the last numbers, we see that cycle count is 220. Oh, that's silly. That's not at all what I wanted. I knew that was 220. That was the whole point. This is X register. Here's the run test button. Okay, so when it was 220, the X register was 19. It should be 18, and we're off by 1. Okay, but I knew that already. What is the command that we are currently about to be thinking about? Okay, we are about to be thinking about the no-op because we're on 19. I think that's because we just added a 1. When does cycle count increase? What if this just starts at 1? Haha! There we go. Cycle count just starts at 1 and everything is happier. Okay, that still works for my input. Awesome. Okay, so now we have refactored part 1 to be by clock cycle. Okay, so now we can do the printing part. Okay, so we are printing in a specific bit here. So this is really just gonna become be a CPU. I'm just gonna call this method be a CPU. That sounds fun. Be a CPU. And it's going to return the eye size, but it's going to print out something when it runs. It's just what I've decided. Okay, so if we are at cycle, so at cycles that are divisible by 40, we're going to do a new line at the end. Is this relevant to me like at all anymore? Kind of not. Record signal strengths. But then the other thing we want to do is draw board. Okay, so we want to say the cycle number and x. So if x register -1 dot dot x register +1, we'll use what Broken Spy told me about and do the inclusive range has an equal sign instead of triple dots. It's dot dot equals. So if we go from 1 below register 1 to 1 above register 1, if that contains the cycle count, then I think we want to print a dot. Oh no, then that's a dash. Else it's print a dot. Does it not? Oh wow, it doesn't like printing characters. That's kind of funny. Expected a reference, and then if cycle count mod 40 equals 0, print line with nothing. Okay, now then if we run this, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But like, why does that? I guess that just doesn't look like the answer that we got. So actually, do I need to go to 240 now? Now I think I don't want to break when we're done with the interesting things. That could be the case, except this isn't far enough. But that does look right. Oh no, they're all in pairs of 2. These are not all in pairs of 2. Okay, so that doesn't look right. Yeah, and there isn't any continues or anything weird happening at the moment. Oh, well, there's this break. Oh yeah, well, that's just if we're... less than length and, yeah, because we only need to do these, and we don't have to break at the end. Oh yeah, that's the only way that was actually the only way we broke out at all. If cycle count is greater than or equals 240, then we'll break. 240. Yeah, okay. Okay, so that got all the way to where I wanted it to, but we stopped coloring them pretty quickly. Finish executing X, add X, it's now 4. So it's just, does this like not go negative? Like, I think it does. Finished executing this. Yeah. So it just goes dot dot, it just goes back and forth between the two at first. Why does this register? Okay, I guess I just need to like print out a few more and see what's going on, but eventually my register just get like completely out of whack, it feels like, with the ones from there. Um Problem is if I add a debug statement, I think it's gonna just completely wreck this. Cycle count and X register. Like I think this is just gonna completely wreck these prints that I have here. Yeah. But we get all of these, and then we get one of these, and like it's pretty, like it's like kind of close. Okay, cycle 1, X registers 1, cycles 2. Oh, wait a sec. Okay, but did the off by oneing mess this up? Cycle, so that's gonna be cycle 40. Oh yeah, maybe it did. No, no, that's totally fine. Okay, let's do this. If I don't think it's cycle count. CRT. Okay, so it's cycle count mod 40. Gotta be cycle count mod 40. Equals cycle count mod 40. We want to know if that contains the M. And if that's 0, then we print line, because that means we are done with a thingy. Okay. That at least looks more right. Yeah, that looks right. Okay, let's get rid of the debugs. Okay, that looks moderately right. Can't tell though. Nope, that's not the same. This is just definitely not the same. Yeah, It's closer, but it's not the same. Okay. I need to figure out this I think it's definitely this drawing bit here. Like the CPU, the CRT is tied closely to a CRT draws a single pixel during each cycle, representing each pixel on the screen as a thing. Here are the cycles during the first and last pixel in each row are drawn. Yeah, so cycle 1, cycle 40, I get that. If a sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit thing. Okay, so the first few pixels start cycle 1. Begin adding the adder. During cycle 1, CRT draws pixel in position 0. And 0 is close to our X register. CRT draws pixel in during cycle 2. It draws pixel in position 1. This is still close to 1, so we do this. We finish executing 15, and register X is now 16, so it's far away. We're now drawing this dot. Since it's far away and we're drawing this dot, we don't do it. We're drawing this dot, it's still far away. Yep, finish executing, and it's now 5, and we're about to print 0, 1, 2. Oh, so this was zeroed though, right? This started at 0. Do I need to subtract 1 here for like freaking off by 1 errors? That's what it feels like. It feels like what I need to do is cycle count minus 1. And then this is not equal to this anymore. This is cycle count mod 40 equals 0, because that still felt right regardless. This thing's just being weird. That's it. That's what I'm looking for. Okay, so part 1 still passes. Part 2 still passes, and we get ZCB. Okay, let's do it this way. Cargo test. Oh, I actually don't get to see it this way because it doesn't show me the print lines. Okay. ZCB. ZCB. AJ. AJ. FJZ. FJZ. Woohoo! Okay, those ones are interesting. I'm not a huge fan of having to read them. I like it when I just get a number that I can copy paste, but that's okay. That definitely did look like a ZCBAJFJZ. Awesome. Okay, so that is day 10, part 2. Once we got part 2 restructured to be by CPU cycle, it wasn't awful, but that restructuring definitely took a second. So we made our commit. Let's push it up now. And there we go. That will officially wrap up Advent of Code Day 10. Thanks for hanging out with me. I hope you're enjoying the videos. If you are, please give this video a like and subscribe to my channel to know when future videos are coming out. Day 11 will be coming at you real soon. Thanks. Bye.